Hey everybody, Dave Igo here, bringing another video about tips and tricks for tube laser. This is the table for our trade show display. If you go over to my portfolio pages, you can get some great pictures of it. And I'm really pretty proud of our trade show display. You can see there's a series of tab and slot here on the edge, and this whole thing, the entire display, which is massive, tab and slots together. There's not a single bolt used in its construction. It's pretty cool. Anyway, go over to my portfolio page and check it out. But I've been getting a lot of questions. Let me normalize this view about how I modeled this joint right here for the tube laser. And this joint, when it's not bent, looks like this. So this is what we actually cut in the tube laser. Okay, and then you're able to just bend that by hand, and you zip one little weld across the inside, and it winds up looking like this, and it's pretty cool. But anyway, I've been getting a lot of questions about how I model that, so I figured I would show everybody exactly how I did it, and I think it's going to take us 10-15 minutes here if I don't muff something up, so let's give it a shot. Okay, so what I've done is I've created a new part, and what this part is, this is the profile, or I guess this is our bent tube. It's a 2x3 12 gauge, so it's 104 wall, and you can see what I did here was I just went in and created a sketch on the top plane that represents the profile of the tube, and from there I extruded it into a block. I put the fillets in for the corners, and then I shelled it out. Now, a quick note about the corners here. What is your corner radius? It's very important when you're designing for tube laser that you know what that corner radius is, and that's going to become more and more apparent why that's so important here as we go along. But a good rule of thumb is 1.8 times your wall thickness. Okay, 1.8 times your wall thickness. So this is a 104 wall, which gives me a corner radius of 187 and 2/10, I think it is. So we've got our corner radius set at 187. So this is a 10-inch radius. I picked that because I like the way it looks. The easier the radius, the easier this tube will be to model and to bend accurately. So we've got our piece of tube. So what I do now is I create a sketch on the face of this tube. And this is the line that's most important, this one right here, because we want our bend to start at the tangent line and stop at the tangent line, okay? So that's the most important one. So what I'm going to do is I'm going to put a little clearance in here. I'm going to offset this by 10 thousandths and make sure I'm going the right direction here. Great. So that gets me 10 thousandths away from the corner radius. Okay, so that's important. The next thing to do is, and I'm not going to be a real stickler here for dimensions. I may even leave you with a sketch or two that's not completely constrained, but you'll figure that out. So I'm going to put this in here like this, and come back and trim most of this out. Okay. So this is you're kind of getting a feel for what this is going to look like now when we're done, right? Let's offset this line another 10 thousandths. You'll see why in just a minute. And we don't want to make the construction base in this case. Okay, so now we have two lines 10 thousandths apart that are also 10 thousandths off of the corner radius. Okay. So now let's take this line here, and you know what, just so we don't run into trouble, I'm just going to fix a couple of points here and constrain that. I know that's not the right way to do it. My CAD guy would yell at me for doing it that way, but it's going to have to get us through. So now we have the basic shape or outline, okay? So now I want to take this, and I'm going to go offset 10 thousandths, bidirectional, make construction base. Okay. Whoops. Well, we'll have to do it in a few steps because I made a mistake. You know what? Let's go back. Let's undo that. Offset 10 thousandths bidirectional, and let's do this whole line this time. Okay? So now we come up here and trim some of this out. And we'll go like that. I don't know what this little guy here is. We'll get rid of him. Okay. So we'll do that. Let's run these down just a little bit. And let's just cap those. Okay. Oh, you know what I did? Let's try this again. Let's come up here. And let's try it again. Through all. Boom. So this is a fair representation of what we expect this joint to look like when we're all done. I'm going to go in and save myself just a little bit of trouble here, and you'll see why in a second. Let's give some, I'm going to put some corner radiuses in. So we'll go 125 on the two ID corners, and we'll go 135 on the two OD corners. Okay? So this is a pretty fair representation of what this cut's going to look like, right? I think everybody would agree with that. Okay, so what I do now is I go over, incidentally, I think I showed you in the first video, but this is what this thing's going to look like when we cut it in the tube laser before we bend it, okay? It's going to look, for the most part, like this. Now keep in mind the tube laser is always going to normalize these cuts. I've got a video on tube laser normalization. I would suggest that you watch that if you don't know what that means. But the tube laser is going to normalize and interpret this cut a little different. And that's the reason for my large, quote-unquote, clearances of that I put in the previous video. So let's just get rid of this. We don't need this anymore. So what I've done now, let's go in. This is just a piece of tubing, okay? And you can do this any way you want. I just drew it in as an extrude. I didn't go in and put in a structural member, which would have been the righter way to do it. But this is quick and easy, and it'll get the job done, so that's what we're going to do. First thing I want to do here is I'll mark off my center line, and then I'm also going to convert this edge and make that a construction line. Okay? Great, so I've got this. Now we go back over to this right here, and instead of editing the sketch, what I think I want to do, what we're going to do, first let's come up here to this cut, okay? And I should turn my acceleration off, but let's just measure this real quick. So we've got a chord length, actually an arc length of 7.699, okay? 7.699. So what I'm going to do is I'm going to come in here, I'm going to draw a line, and select the midpoint, mate that to my vertical, and make it 7.7. Close enough, guys. Come on, it's only 1,000th, actually not even. And set this 10 thousandths off of my corner radius. Okay, so now I've got this line in here, and we know we need 10 thousandths on the ends. So we'll draw these two little lines in here. I'm going to select that point. Select that point. Mate them horizontally. And set them to 10 thousandths length. Okay, so now we're all set up. So now we come back over to this joint here, and let's just make a new sketch because it's easier. And I want this line, this line, this line, this line. You know what? Let's get this going. Okay, so you see what I did? I just copied that sketch, okay? And we'll close out of that. And now we're going to select everything. Control C to copy. Go back over here. You have to have a sketch already open. And Control V to paste, okay? Select all of that. And I want to rotate 22.5 degrees, right? Half of 45 degrees is 22.5 degrees. I'm going to pick the center of rotation as right there. Okay. Simple as that. Grab it all, move, and we're just going to go from to and select that point. And that point. Okay? And we'll come back over here. And we're still in the sketch, so let's just go ahead and delete all of that geometry. We'll go convert. I want that line. That line. Okay. Select it all. Control C to copy. Back over to our other sketch. Click down here. Control V to paste. And select everything. Rotate. Pick your center of rotation. And then we're going to go minus 22.5 degrees. Okay? Because again, half of 45 degrees is 22.5 degrees. We'll select this whole thing and go move. Select this point. Come up here and mate it with that point. And now you'll notice these are short. There's a reason they're short. Let's go back over here. If you notice when I selected, I didn't finish selecting the tail of the tube down there through the radius, and that's why they're short. So this is pretty simple. I'm going to fix that. I'm going to fix this one. Drag the ends down. Do that. And through all. And look at what we did. Okay? So it's really that simple. And now that's how we're going to cut this in the tube laser. This is 104 wall with a 3/16 outside corner radius, but you will be able to bend this by hand. You'll be amazed at how easily it bends. It gives you a whole new set of cautions when designing for steel tubing. You'll have to cut a test. You'll have to cut a test one of these because, like I said, the laser will interpret and normalize this different as it comes across this radius here. The rest of it is actually going to cut exactly the way you're seeing it. This will be the only problem, is this transition area. And again, I've got a video on that laser normalization that I would encourage you guys to go watch because there's a lot of valuable information and one really, really cool trick that I figured out that is now saving my entire CAD department lots and lots and lots of time, as well as making the ops guys much more happy. But anyway, so that's that. That gets you this one right here, or pretty dang close to it. And so I would just want to say thanks for paying attention and thanks for watching. Out all my other videos, I've got a lot of great tips and tricks, especially when it comes to tube laser and tab and slot construction. If you've got any questions, please feel free to email me, daveigo@daveigo.com, and we'll see you in the next video. Thanks, everyone.